I'm going to look at a two-sample t-test, and this is the comparing two means from the same data set. So if in the one test for one mean we were looking to see if the average hand grip strength overall in this data set was the same as some other value that we might have got from a different research paper. Now we're looking inside this data set to see if there's a difference in two of the groups. So two of the groups we've got here are in the sex or gender. We've got one for females and two for males. If your data set doesn't have this coded in, I think you're going to find it easier to read the graphs if you put some value labels in there. So the null hypothesis in this case is that there is no difference in between genders for average hand grip strength, which is the same as saying that the average hand grip strength for females is the same as it is for males. And this is within a particular cohort of, I believe, over 65s in the UK. So to start off with, we'll just do a quick chart to have a look at the hand grip strengths, and we've probably seen this already in previous tutorials, but we'll do it again. So we've got a box plot open, and we're going to have a look at hand grip strength up the y-axis and sex on the x-axis. Okay. So we can see here that they actually look kind of similar. They both go down to 0, so both groups had some people with very, very low hand grip strength. And then we had a few people in each gender that had higher hand grip strength, and we've got, and these are all outliers far away from the rest of the data. And we've got one gentleman up here who scored quite high on the hand grip strength. We can have a look at the medians here, and they look fairly similar. And we can now do a test to see if there is statistically any difference between these two groups. So the null hypothesis is that there is no difference between the two groups, and the alternative hypothesis is that there is a difference in the two groups. It doesn't tell us what the difference is. We would have to then go and look at some confidence intervals around the means to look at what the difference might be. It would just tell us if there is one. So if we go to Analyze, Compare Means, now to look at two means together, we've got the choice between an independent samples t-test and a paired samples t-test. The paired samples is if you've got two values that go together for each participant, depending on what your study is, of course. So if, for example, we had measured the left hand strength and the right hand strength on each person, then those values, the left and right, go together, and we need to take account of that in our analysis, and so that would be a paired samples t-test. In this case, we've just got women and men who are independent of each other, and so we've got an independent samples t-test. So if we click on that, our test variable is average hand strength. Our grouping value is sex, and you'll see here that it wants us to define the groups. And we'll just put in here, I had 0 and 1 because I just wanted to see what it would do if I put in values that didn't exist. If you look over here on the data, you can see that our sex is divided up into groups which are labelled 1 and 2. Sorry, they're coded 1 and 2, and they've got labels of female and male. It's possible that you may have, excuse me for a minute, I've got a cough. Okay, I'll just pause that while I cough. It's possible that you may have a grouping variable which has more than two groups, and for an independent samples t-test you can only test two groups, and you might want to pick two of them. So for levels of arthritis we've actually got 4 levels, but we might be interested in just comparing the lowest level with the highest level, for example. In next week's work we'll be looking at testing several groups together, so I can't imagine why you would want to do an independent samples t-test for just two groups out of several when you've got other options. Okay, so in any case we need to define the groups we're looking at, and they're 1 and 2. Group 1 is 1, Group 2 is 2. Okay. Options, we can just leave that at the 95% confidence level. That's fine. Okay. So the first thing we get is a little summary of the data. You can see that we've got more females than males. The females had a lower hand grip strength on average than the males. They also had a lower standard deviation and a lower standard error of the mean. So the question is, is this difference in hand grip strength between females and males statistically significant? And that's what we're going to test with our independent samples t-test. What you've got down here is actually 3 tests altogether, so it might take a little bit of practice in reading the information that you're interested in. Now, the reason that there's 3 tests is because this test for equality of means, so does the mean for women equal the mean for men, the maths behind it actually changes a little bit depending on whether or not the variation is the same in both those groups. So you can see here that it's possible that there is more variation in one of the groups than the other. Actually, these two look very similar, but it's always a possibility. And so what SPSS does first is it tests to see if the variances are equal, and then it gives you 2 versions of the t-test, one based on if the variances are equal and one based on if they're not equal. So I think in the answer sheet I have just used the variances assumed equal, and that would be fine to just use that. If you're interested in the test for variance, it's the same as any other test. The null hypothesis is that the variances are the same. We have no evidence to reject that. The significance is quite high, and therefore we will assume that the variances are in fact the same for both the groups, for males and females. So that's assuming that we've got the same amount of variation in the hand grip strength scores for males and females. So these 2 columns are only about the variances, they're not about the means. Over here is where we've got the test for the means, and we're just going to look at this top row here. So we've got a test statistic here, we've got degrees of freedom that goes with that for doing the test. You're welcome to look up the mathematics behind the test if you're interested. It's not too difficult if you want to have a look at it. Probably most important for us is that we can find the p-value. So you'll find that most papers do report the test statistic. They'll say a t-value of this, and this is what they're reporting. It's this value here. And it's a little bit difficult to interpret this if you're not familiar with how the test works or what a t-distribution looks like. So for the moment you can probably ignore that. What we are really interested in here is the significance, which is our p-value. And you can see here that for this test it's actually quite high, 0.26. So what this tells us is there is a 26% chance of observing our data here if this null hypothesis is true. That is, if the hypothesis that the means are the same for men and women is true. This means that we have got no evidence to reject the null hypothesis, and therefore, based on this data, we'll say that the average hand grip strength for women is the same as it is for men. This test does not actually prove that the hand grip strength for women is the same as what it is for men. What it shows is that we've got no evidence that they're different. So if somebody else did another study, possibly with more participants, it's possible that they could pick up a difference in hand grip strength between males and females. But whatever that difference is, it's probably small, and we haven't been able to detect it. So you're never able to prove that the null hypothesis is true. You can just show that you have no evidence against it. If you want to pick up a very small difference in groups, generally speaking, you need a very large sample size to detect it. If you suspect that the difference between the 2 groups is going to be very large, then you only need a very small sample size to detect it. So say we wanted to test how far 5-year-old boys could throw a tennis ball compared with their fathers. We would expect a very large difference between the 5-year-old boys and their fathers, and we would probably only need a small group, let's say 30, 40, 50 participants, and we would be able to pick up that there's a significant difference in the length that a 5-year-old can throw the ball and that their father can throw the ball. If, however, we were testing 18-year-olds against their fathers, any difference, if there was one, would be really, really tiny, because the 18-year-olds would have massively caught up to their fathers. So in that case, if we wanted to detect a difference, we would expect that the difference would be very small, and therefore we would need a much, much larger sample size to pick it up. So in this case, we have no evidence that there is a difference between the males and females. It's possible that one exists, however we can't detect it in this data set. suggesting that we would need a much larger data set to pick it up, and that any difference that does exist is probably small.